Welcome everyone. In this video we present our final project, a traffic light system for pedestrians and vehicles built entirely with digital logic and discrete components. Our model represents a real intersection with a street, houses, trees and benches. The vehicle light remains green and the pedestrian light red, but the pedestrian crossing is only enabled when the user presses a switch 5 times. To implement these systems, we use 3 JK flip-flops from dual integrated circuits, a dip switch that functions as a push button, and double AND gate, a triple AND gate, a NOT gate, and 4 LEDs that simulate the light of both traffic signals.
Now we're going to explain the internal operation of the system and how we managed to make the traffic light respond exactly after 5 activations. Our circuit is based entirely on sequential digital logic without microcontrollers or programming. To achieve this, we use 3 JK flip-flops, which together form a binary counter. These flip-flops come from dual JK integrated circuits, but we only need 3 of them to store and process the sequence of states required for the system. The process begins when the pedestrian interacts with the input switch. Each time the switch is activated, it generates a signal that advances the counter to the next state. The JK flip-flop are configured in toggle mode, which means each coming pulse changes their state. Working together, the 3 flip-flops move through a series of binary values, and the system keeps track of how many times the switch has been activated. To detect the exact moment when 5th activations occurs, we use a combination of logic gates, a double AND gate, a triple AND gate, and a NOT gate. These gates read the output of the flip-flops and identify the specific states that correspond to the 5th activation. Only when all the required conditions are met at the same time does the output signal activate. When this happens, the signal control on the LEDs is triggered. At the moment, the vehicle traffic light temporarily switches from green to red, while the pedestrian light changes from red to green. This state is maintained for a short period between 3 and 5 seconds, which should a short interval to keep demonstration smooth and clear. Finally, once this time has passed, the system automatically resets the counter using one of the flip-flops and the LED returns to their normal state.
Now we will see the behavior of the system in operation. Here we can observe that the vehicle traffic light is in green, so this means that the car can move freely. But the pedestrian traffic light is in red, so this means that they cannot cross the street. We activate the dip switch 5 times. With each change, the internal counter advances, and when it reaches the corresponding value, the circuit generates the state change. Pedestrians receive a green light and vehicles must stop. Here you can see that the car can't move and the pedestrians can cross the street with freedom. When they reach the other side, and after establishing the crossing time, the system resets and automatically returns to its normal state. This project demonstrates how it is possible to replicate the functioning of the real traffic lights using only basic digital logic without the need for microcontrollers. And well, to finish my part, something we felt was important was making sure the traffic lights operation was clear and understandable to anyone watching. That's why we organized the circuit so that the lights, wires and components were visible and easy to follow. We also did several preliminary tests before recording, simply by activating the switch and observing how the lights progressed, so that the final demonstration will run smoothly and without any issues. Ultimately, what we wanted was to demonstrate the concept practically, that with sequential logic, flip-flops and some gates, we can recreate real-world process like a traffic light, and all throughout we kept it short to avoid making it tedious. We believe it's still very clear how it works and what the project's main idea is. Thanks for watching and have a nice day.